So now let's solve a worked example on overhanging beam. That is, one part is simply supported and it overhangs at one side. That is at side A with a load of 2 kilonewton, uniformly distributed load of 2 kilonewton per meter and point load of 5.5 kilonewton over 2 meter, 3 meter, and 2 meter. Now, as usual, the first thing we do is look for our reaction. So now our reaction at B times this distance here, which is times 5, would be equals to our reaction at B times 5 would be equals to, we have 5.5 times here, we have 5.5 times 2, then plus 2 times 5 square divided by 2 plus 2 times 7. So we have RB times 5 is equals to 11 plus 25 plus 14, which is equals to 50. So divide both sides by 5, 5 cancel 5, that is equals to 10 kilonewton. So we have our reaction at B is equals to 10 kilonewton. So we have gotten our reaction at B. The next thing is to find for our reaction at A. Now, the reaction at A plus the reaction at B is equals to the total shearing force, which is 5.5 plus 2 times 5. That is this 2 times the entire 5 distance plus 2 kilonewton. So we have RE is equals to 5.5 plus 10, that is everything is 17.5 minus RB. RB is equals to 10 kilonewton. We have minus 10, so that is equals to 7.5 kilonewton. So that means RA is equals to 7.5 kilonewton. Now, since we have gotten our reaction at B at 10 kilonewton and our reaction at A at 7.5 kilonewton, then we can proceed to solve the question. Now, our shearing force at D, yes, that the last point there, our shearing force at D would be equals to only this. It will be equals to minus 2 kilonewton. Now remember your bending signature point. If it is creating a deflection or something like this, that is the load is creating a deflection or something like this, we have negative, and if the load is creating a deflection of something like this and something like this, that is it is pushing it upward, this is a positive sign. So something like this is pushing it downward, pushing the load downward, that is a negative sign, while this one is pushing it upward, is a positive sign, that is bending and hugging. So this here is negative because this load is pushing it downward, is causing a downward bend. So that is for that. Then the shearing force at B will be equals to minus 2 plus the reaction at B here, which is 10. It will now be equals to 8 kilonewton. So that is our shearing force at B. Then our shearing force at C. Our shearing force at C, now we have two shearing force at C. We have to calculate the shearing force without the point load and the shearing force with the point load. Now the shearing force at C, let's say from the right, from shearing force at C from the right, that is equal to minus 2 plus 10, then minus 2, which is this one, times 3. So which will eventually give us 2 kilonewton. So the shearing force from the right is 2 kilonewton. Now the shearing force of C from the left, the shearing force of C from the left is equals to minus 2 plus 10 minus 2 times 3 minus 5.5, which will eventually usually give us minus 3.5 kilo Newton, negative 3.5 kilo Newton. And then our shearing force at A is going to give us negative 7.5. But let me prove it. So our shearing force at A will be equals to minus 2 plus 10 minus 2 times 3 minus 2 times 3 minus 5.5. No, not minus 2 times 3. Minus 2 will go over the entire span. That is minus 2 times 5, then minus 5.5 digits. So this is going to give us minus 2 plus 10. We have 8 minus 2 times 5, that is minus 10 minus 5.5. We have 8 minus 10, that is minus 2, that is equals to minus 2 minus 5.5 equals to minus 7.5 kilo Newton. So therefore our shearing force at A is the negative of reaction A. So that is for that. We have gotten our shearing force of this. Now we move on to the bending moment. Now our bending moment at D is obviously zero because no force is applied at a particular distance from it. So that's our bending moment at D. Now for our bending moment at B, we are going to be replacing this minus 2 times the distance. So we have minus 2 times this distance here, which is 2, is equals to minus 4 kilo Newton meter. That is the bending moment. Now for the bending moment at C, the bending moment at C, the bending moment at C would be equals to, we have minus 2 times the distance from here, that is times 5. And we have plus the reaction at B, which is 10. We have plus 10 times what is the distance? 3. And the uniformly distributed load that is applied from here to here, so we have minus 2 times the distance, 3 square over 2. So if we solve this, we have minus 10 plus 30, then minus 9. So that is equals to 30 minus 19, which will give us 11 kilo Newton meter. The bending moment at C is equals to 11 kilo Newton meter. Now for our bending moment at A, we know that that automatically is equals to 0. The bending moment at A is automatically equals to 0. So that is for that. And if you are thinking about where is the point whereby the shearing force is equal to 0, now we notice that at the shearing force at C, we look for it 2 times. We search for it 2 times. That means, and at that 2 times that we search for it, the first one give us a positive, the second one give us a negative. That means it is still at that shearing force point C is where we are going to get our maximum curve of this U.D.L. We are going to get our maximum curve, and that maximum curve BM of C is equal to 11 kilo Newton meter. Now moving on to drawing of the diagrams. So we trace our line down here. Now for our shearing force, we draw a neutral line straight right here. Now our shearing force at D is equals to minus 2. We have minus 2 downward. We have downward here. We have 2 kilo Newton. We have 2 kilo Newton right here. Then our shearing force at B is equals to 8 kilo Newton. That means these two, since it is a point load, we have a 1 degree line up to this point. We have a 1 degree line up to this point, and it goes up to 8 kilo Newton. So here we have 8 kilo. Here we have 8 kilo Newton. So from 8 kilo Newton, we have a U.D.L here. Then from shearing force at B to shearing force at C at the right, we have 2 kilo Newton. So we take it at an angle to 2 kilo Newton. Here we have 2 kilonewton. And also I mentioned that at the shearing force, it's at the same point we found for it at the length, we got minus 3.5. So minus 3.5, we take it down here, minus 3.5, we take it down here, we have minus 3.5 kilonewton. And our shearing force at A minus 7.5, we continue our slant line here, we have 7.5 kilonewton. Let me move the minus. So we have this as negative and we have this as positive. So now this is our shearing force diagram. Now to our bending moment diagram, let me put a little bit of highlights. Let me put a little bit of highlight here. We have positive and we also have negative here. So that's it. That's our shearing force diagram. And now for our bending moment diagram, we put our straight neutral line right here. Bending moment at D is 0. Bending moment at B is -4. So we take it at angle a 1-degree line to -4. And from -4, it goes to bending moment at bending moment at C, which is 11 kilonewton meter, and comes back to the bending moment at A, which is 0. So the curves go some way like this and down here. So here is positive. We have 11 kilonewton meter here, and right here we have 4 kilonewton meter. That is, this one is negative and this one is positive. So that is all for the diagrams of this. And now you notice that right here we have a point here, we have a point here whereby the bending moment is equal to 0. The bending moment is equal to 0. So we can be able to calculate for that point where the bending moment is equal to 0, and that point is known as the point of contraflexion. That point where the bending moment is equal to 0 is known as the point of contraflexion. We can find for it, let's say there is a distance x from here, to find it for the bending moment at x, which is equals to 0 here, that point where bending moment is equals to 0, is equals to, we have 2 times the distance, that is 2 times 2 plus x, 2 plus x, then the reaction from here, we have the reaction plus the reaction, which is 10 times x, that is 10x, and this 2 here will be negative since this one is pointing from the upward direction. We also have the U.D.L here, which is minus 2 open bracket x square all over 2. So here we have, if we continue, we will have minus 4 minus 2x plus 10x minus x squared. So we end up having minus 4 minus 2x, we have minus 4 plus 8x minus x squared is equals to 0, or 0 is equals to this. So we can use completing the square method. We can try to use completing the square method, whereby x is equals to plus or minus, x is equals to plus or minus b square root of b square minus 4ac all over 2a. We can use that, and we can also decide to use the factorization method if we can find something here. We can decide to use the factorization method if we can find something there. But given that this is a quadratic equation, we are most likely not going to find one answer. We are most likely going to find more than one answer. So that is for that. But to find for the bending moment, to find for a point of contraflexion, you just find for the bending moment at where the bending moment is equal to 0, and the value at x, then you'll be able to get the value of x.